You're going to be doing grade, the idea of grade calculations, but you're also going to do a little bit of statistics while you're doing grade. Now the whole first part of this, I should have mentioned this before, make sure somebody in your group has a TI graphing calculator. I'm assuming that somebody does, yes? We may have to shuffle around if that isn't the case. And the idea is, if you don't have a TI graphing calculator, we'll have to simulate some kind of a die, like a die roll or a coin flip or something. If we have to figure that out, we'll figure it out. If somebody has a smartphone, that will work as well. So if a group does not have a TI calculator, grab me when we're done this, and if you have a smartphone, there's a workaround we can use to get the job done for today. Cool? Okay. So the idea is we're going to send you guys out and about throughout the quad here, and you're going to be measuring the average grade on the stairs, some of the sets of stairs that we encounter. That's why I gave you the tape measure. You're measuring rises and runs. But the idea is I want you to draw a sample. I don't want you measuring every single stair in each set. I want you to measure a representative sample of the stairs. Now, in statistics, we often do this. For example, how many of you have ever heard of something called a side effect from a drug? Side effects from a drug. Okay, so give me a working definition of what a side effect is.
Liver failure.
Oh, good. Liver failure. Okay. That is an example of side effect, yes. Anal leakage. These are many side effects, exactly. That was, remember Olestra?
Yeah.
Remember Olestra? It was a fat substitute in chips. That was one of the side effects. As Robin Williams says, that's not a side effect, that's an effect. No. So a side effect essentially is some unwanted happening that comes along with the use of a drug or a treatment. How are side effects measured? How do you know, for example, let's not talk about anal leakage or little finger. Let's say headaches. Let's say headaches are a side effect of taking a certain oral medication for something else, for heart disease. There's a heart disease medication, but it gives you headaches as a potential side effect. How do they know it gives you headaches? Amber, as a potential side effect. Or go ahead.
Are you looking for when it becomes more severe than the outcome of the medication?
Boom. Oh, that's when I don't know how they judge that, but how do they know that someone who takes the medication has headaches at a higher rate than someone who doesn't?
They take a sample.
Boom! I heard a sample and I heard the word control. What they'll do is they'll take what's called a randomized sample of two groups of people. And one group of people they'll give a drug to that contains whatever medicine we're talking about. Dean, I'm sorry, she survived 244 with me already, so she's heard this. One group gets the medicine in a little pill. The other group gets a little pill that has nothing in it. Placebo, exactly, a sugar pill, placebo. And then they measure the intensity of headaches in both groups, and if the intensity of the headaches in one group is spiked compared to the second group, then we say, ooh, this might, and if it's within that range, Amber, you're talking about, then we say this might be a potential side effect. Headaches might be a potential side effect of the medication. But all of that goes back to what's called a randomized sample. And the idea of a randomized sample is making sure you're picking somewhat randomly from whatever population you're studying. So that's what the whole first page of this quiz is about. The second page of the quiz is where you actually collect your data. The first page of the quiz is setting up your calculator to help you pick stairs randomly. So what I did was I put a little picture of stairs just to give you something to work off of. And I numbered the stairs 1 through 9, because in this particular set of stairs there were 9. You may have 6, you may have 7, you may have 10, you may have 15. So you'll have 1 through whatever. This is a way of setting up your TI to pick random numbers. So you pick random stairs that you're going to measure. You're going to measure exactly 5 stairs, rises and runs. So altogether, you're going to pick 5 stairs, rises and runs. This is a way of picking them randomly, so you don't just start at the top and measure down. Why might you not want to just start at the top and measure down? What would be and this is a statistics question. I want to plant these in your minds as we go through this course, because I want you to think about this. What would be a problem with starting at one end and working your way down and just measuring those and calling it good?
Because one could be slightly off.
Well, that would actually be ideal from a construction point of view. That's true, though, Amber. That's very true. That's true. There might not be enough variation. You might not catch some variation. Somebody said something about being off?
Yes.
Frankie, go ahead.
Slightly off.
Yes, and here's the deal. What Amber just said was the first 5 might all be the same. Suppose somebody is constructing something. Now stairs are they usually build forms and then pour concrete into them, so it shouldn't be an issue. But suppose the forms changed as they went from top to bottom. They were building the forms incorrectly and it got worse as they went down. Error was propagated. If you just measure the first 5, you might not catch that error. It might look too good. The ofteness might not be measured. If you pick a random sample within it, you might actually catch a better indication of what's going on. Fair enough? Good. You guys okay warmth-wise? It's a little cold. I'm seeing something. No. We'll start moving, yes? So basically, get to your stairs. Get to your stairs. If you're getting really cold, you might want to go in a building and do the first page, and then go to your stairs, and then just collect the data at the stairs. And once you're done collecting, here's what you're going to do. On the back page, the points come from writing down the rise, run, and grade, and which stairs, fill in the data set in. And then number 2, it says calculate the average grade of all 5 of the stairs you measured. Everybody know how to take an average? If not, let's do this. Collect the data in this table, and then we're going to meet together in Ochako 221. I got a new room for us to go to, so we have to walk back to the library. Ochako 221 when you're done collecting your data, okay? So everybody just scatter, do what you got to do. I'll be right here. I'm going to measure something else, because I want to check something grade-wise as well that I didn't check last time they put it in. Okay? Have fun. We'll see you at Ochako 221, or just shout down if you get stuck with something. Yes. Happy hunting.
Did you guys watch the documentary?
I don't know. But I know.
Figure it out.
But I know that Jenny Cruikshank in Total Fit makes us run. We call them Grandview Hill repeats. We start at Mazama and run right up here, touch the door on Grandview, and run right back. We do it like 5 or 6 times. So it's hellish, whatever it is.
I count 1,200 steps, which is
1,200 steps.
a little over a half mile for me.
And then if we knew what the average grade for a step was, we could figure out what that was as far as a rise.
2.2.
Well, 2.2 feet, but whatever the grade of each step was, and that's the trick. I don't know. I'd have to measure we'd have to take a GPS with us.
Yeah, I tried it with a topo map.
Well, that's tricky. That could be
That's like
tricky.
about 70 feet.
Yep, and that makes sense because I think it's 95 feet higher from my new office in Grandview to my old office in Pioneer. So 70 feet would sound about right because I'm going higher to Grandview than to here. So I would believe that. Yeah, that's arguable. Topo maps are great except with a 50-foot